The Crab Nebula is 1.5 parsecs in radius, and its expansion speed, measured from Doppler shifts, is 1,500 kilometers per second. Wow. A little calculation soon shows that 1.5 parsecs is around 1,500 kilometers per second times 1,000 years. The Crab Nebula shows all the signs of being the expanding cloud of debris. It's an expanding cloud of debris from an explosion about 1,000 years earlier. So if you have an explosion, the nice thing is that the debris will slowly, disperse. And guess what? That's how we are here. If the debris from stars exploding did not go everywhere, slowly but surely, there would not be elements making us today. Yeah. Isn't that amazing? Yeah. I thought so. That's the usefulness of astronomy. It's not useful, but it's amazing. The Crab Nebula shows all the signs of being the expanding cloud of debris from an explosion about 1,000 years earlier. In the center of the Crab Nebula is a pulsar. Your favorite. The Crab pulsar has a period of 33 milliseconds and is seen to pulsate at radio, visible, X-ray, and gamma ray wavelengths. The pulsar is in the Crab Nebula, just where you'd expect the neutron star. It's a classic smoking gun piece of evidence that neutron stars are basically pulsars and pulsars are neutron stars. So the Crab Nebula, so why is it a Crab Nebula? Because there was a supernova there. The debris over time, over 1,000 years, has been expanding and dispersing. So it's no longer just a compact thing. It's been kind of like going everywhere. So we see it as a nebula. We call it the Crab Nebula. It's famous. And so it's this more extended thing that we're picking up on. And in the center of the Crab Nebula is the evidence of the death of that star. That star eventually died down to a neutron star. It's a pulsar. Because stars, when they die, they eventually become a remnant. It's either a white dwarf or a neutron star or a black hole, depending on the initial mass of the star. This was a pretty massive star that exploded, that died, leaving behind a neutron star. The Crab pulsar has a period of 33 milliseconds, so it's not too bad, 33 milliseconds, and is seen to pulsate at radio, visible, X-ray, and gamma ray wavelengths. Wow. So you can pick it up with all of that. You know what I mean? Like the detection can be in any of it. And I'm sure they, built it. The pulsar is in the Crab Nebula, just where you'd expect the neutron star. Curiously, astronomers had been observing the pulsar for years at visible wavelengths without noticing the strobe effect. The pulses were too fast. So if you looked at the pulsar at at the visible wavelength, you might not see all of the effects of it. They had to eventually see it in radio, visible, X-ray, gamma ray. That's why we say multi-messenger astronomy. Like you want to be using multiple parts of the spectrum, whether it be light and maybe even completely other particles. That might also give you some indication. Wow. Thanks for carbon dying stars. Yeah, I mean, not just carbon. Stars that make carbon, that make iron, that make more than iron. All of that stuff can die and make us. Did die and make us. I remember reading something about that golden disk we sent on that craft in the hope of aliens finding it. Voyager and how it described our position using neighboring pulsars. Oh, I don't know about that, but yeah, maybe